Welcome again to today's class on simultaneous equation. Recall, we have posted many videos on this topic, simultaneous equation, and we said that simultaneous equation simply means pair of equations which are to be solved at the same time. We have discussed how to solve simultaneous equation in two variables, that is where you have two unknowns, and we said you have many methods you can do that: substitution method, elimination method, matrix method, determinant method, graphical method. Yes. Then we are now discussing simultaneous equation in three variables. Yes, you have three unknowns, three letters to get their values. In this video, it was specified, or it's specified that we use matrix method. Let's see how to solve this question using matrix method. You will see how you can solve it using determinant method in our channel. So we want to solve it using matrix method. Let's see. We have three unknowns, x, y, z. First thing you do is you write the x, y, z we are to solve is equals to, what are the coefficients of this thing? Coefficient is 1, 2, minus 3, 2, minus 3, 1, 3, minus 1, what? 4. You get the inverse of it. You get the inverse of it. Just write the coefficient, put inverse, then this will be 4, 5, 7. Just when you write x, y, z accordingly, you write the coefficient of each of the letters you have. You put base power minus 1, then you put 4, 5, 7. That is the first step. Now, question is, how do we get 3 by 3, inverse of 3 by 3 matrix? That will take us to inverse of 3 by 3 matrix. Inverse of a matrix denoted by A inverse is equals to 1 over that A times adjoint of what? Matrix A. 1 over determinant of matrix A times adjoint of matrix A. What do we mean? It means that I am to get first of all the determinant of this matrix, which we are looking for the inverse. Remember, 1 minus 1, this power minus 1 means inverse. Okay, we have to get the determinant of it. Let's see how to get the determinant. Determinant of matrix A denoted by this is equals to, hold the what? First column, hold the first row. This is plus, minus, plus. That is their inherent sign. I mean, natural sign it has. And we said that this plus, minus, plus was gotten from A11, A12, A13, B11, B21, please, B22, B23, C31, C32, C33. Add this, any of these that give you odd number, minus, even number, plus. 1 plus 1, even. 1 plus 2, odd. 1 plus 3, even. 2 plus 1, odd. Even. Odd. Even. Odd. Even. That is how we get inherent. So I'm only interested in the first row, their signs. I will say this means plus 1. I will hold the plus 1. When I hold this first row, when I hold the first row, I'm holding the first row. Then I will also have to hold the first column. This one. If I hold it, 4 elements will come out. Minus 3, I will multiply this first. Minus 3 times 4, minus 12. I will put minus because we are looking for the determinant. That minus I put here is constant. Minus 1 times 1, minus 1. Minus times minus will end up giving us plus 1. Then we come to the next one. We say minus 2. Minus times 2 minus 2. Bracket. I will hold the second row. When I hold the second row, 4 elements will come out. 2 times 4, 8, minus 3 times 1, 3. Then I will come to the next one. Plus times minus is minus, minus 3. I have minus 3 bracket. When I hold the third column, 2 times minus 1, minus 2. This times it. So 2 times minus 1 gave us minus 2. We write minus 2, put minus, is constant. 3 times minus 3, minus 9. Minus times minus will give us plus. So what do we have? This is minus 11. 5 times is minus 10. 7 times is minus 21. That will be giving us minus 4 to what? 2. We have gotten our det A, determinant of A, to be minus 42. Then the next thing we have to get is to get the adjoint of the matrix. Adjoint of 3 by 3 matrix. For you to get the adjoint of 3 by 3 matrix, you need to get the cofactors of the rows. Cofactors of the first row, cofactors of the second row, cofactors of the third row. Afterwards, you need to transpose it. So adjoint of 3 by 3 matrix means transpose the cofactors of the rows you got. When you transpose it, you have gotten the adjoint. Okay, let's see how to do it. Okay, to get the cofactors of first row, we'll be saying this is plus. When you hold the first row, this is plus, right? When you hold this as well, hold the first row, hold the first column, you have 4 elements. You now say that plus you see at the first, write that plus, bracket, minus 3 times this, minus, let me write it there. Cofactors of first row plus bracket. That is, hold the first row. You are considering the first row, then hold the first column. You have plus at the first number here. You write plus. You have 4 elements coming out after holding the first column. Minus 3 times 4, minus 12. Minus 1 times this. Minus 3 times 4, minus 12. Put minus. Minus 1 times 1, minus 1. Everything will be plus 1. You put dots, semicolon. You hold the second column. The sign here at the top is minus. The inherent sign is minus. You put bracket. As you hold the second column, 2 times 4, 8. Minus 3 times 1, 3. Then the third element, the inherent sign is plus. Plus, bracket. You hold it. 2 times minus 1, minus 2, minus 3 times is minus 9. Minus 9. Minus times minus plus 9. Okay? That means what we have here is, for here you have minus 11. For here you have minus 5. For here you have 7. You notice minus 11, minus 5, and 7. Please note it. That is our first cofactor of the first row. We go for the second row. I will clean this now. I am no longer holding the first row. I will go and hold the second row. What are their inherent signs? Minus, plus, minus. So I am holding it now. Then the first one is minus bracket, hold the first column. You will now see 2 times 4, 8, minus, this times is 3, minus 1 times minus 3, 3, you have 3. You will now say, this one, the sign is, the inherent sign is plus, plus bracket. You will now say, if you hold this column, 1 times 4, 4, minus 3 times 1 times 4, 4, minus, because I'm holding this. 1 times 4, 4, 3 times is minus 9. So it will be plus 9. Then this one is minus, the inherent sign is minus, bracket. I will now say, if I hold the third column, I'll have 1 times this minus 1, minus 3 times 2, 6. So this will be giving me minus 5, this 13, and this 7. Okay? I'll call again cofactors of the word third row. I'm going to cofactor of the third row. I'll clean the second row I have circled. We are now going for the third row. I'll hold the third row. Their signs are plus, minus, plus. So when I hold this, when I hold the first column, I'll bring down the plus that is in 3. Then I'll put brackets. When I hold here, this 4 elements will come out. 2 times 1, 2, minus, minus 3 times minus 3, 9. Then I will also have that when I hold the second column, I will have that the sign here is minus. The inherent sign is what we are taking. Please don't make mistake and be saying minus times minus plus. Then you write plus. No. Pick out that inherent sign we talk about. Okay? I put the inherent sign minus. Then I will now say, holding this word, second column, I will have 1 times 1, 1, minus 2 times minus 6, 3, minus 6. Minus times minus will give me plus. So plus 6. Then I will now hold this third column. This inherent sign is plus, plus, bracket. I will now say, when I hold here, these 4 elements will come out. 1 times minus 3, minus 3, minus 2 times 4, 2 times 2, 4. Right? Right? So we'll be having here to be minus 7 total. This 7 times is minus 7. This is minus 7. So let's write our answers. Minus 11, minus 5, and 7. Then minus 5, 13, and 7. Minus 7, minus 7, and minus 7. Okay? This is their cofactors of all the rows. This is their cofactor. Then to finally get your adjoint of A, we are to transpose the cofactors we got. We are to transpose it. And transposition of 3 by 3 matrix simply means carry the row, call it the column. Carry the row, call it the column. Carry the row, call it the column. Now this is the first row. I will call it the column. It will turn to minus 11, minus 5, and 7. Then this is the second row. It will turn to minus 5, 13, and 7. And this is the third row. It will turn to minus 7, minus 7, minus 7. So this is the what? Adjoint of matrix A. Adjoint of matrix A. Now, the main work is that we are to get the A inverse. You say A inverse, that is this matrix inverse, is equal to 1 over, what is our depth A? Minus 42, then times adjoint of A, minus 11, minus 5, minus 7, minus 5, 13, minus 7, 7, 7, and minus 7. Let's see what it will give us. This times this will be giving us 11 over 42. This times this, 5 over 42. Adjoint of what? A. Then this times this will be giving us 7 over 42. This times this, 5 over 42. This times this, minus 13 over 42. This times this, 7 over 42. Okay? Then this times this is minus 7 over 42. This times this, minus 7 over 42. This times this, 7 over 42. So we have gotten the final A inverse to be this. Let's summarize our answer. So to summarize it, we now say, since we said that x, y, z is equals to A inverse times what? 4, 5, 7. A inverse, the matrix inverse, times this constant. We will now say that x, y, z. You know, I talk about this by writing the matrix itself. Now, I wrote the matrix itself putting negative inverse. I mean negative power, negative 1 power. That is inverse, meaning that it is inverse of the matrix. Now, I'll be replacing it with what I have. 11 over what? 42. 11 over 42. 5 over 42. 7 minus 7 over 42. 5 over 42 minus 13 over 42 minus 7 over 42. Then 7 over 42, 7 over 42, 7 over 42. Then it will be multiplying 4, 5, 7. Let's see how the multiplication goes. That means to multiply x, to get our x, you say x equals to this will multiply the first, this will multiply this, and this will multiply this accordingly. This times this, 44 over 42. This times this, plus 25 over 42. This times this, plus 49 over 42. That will be giving you 69 plus this. That is 118 over 42. That is your x. Then we call again, so we clean this. We now say for y we hold this, multiply by this, multiply by this, multiply this. Y will be equals to This times is 20 over 42. This times is minus 65 over 42. This times is plus 49 over 42. All of them are in over 42. So I'll write 42. 20 minus 65. Okay, 20 plus 49, 69. 69 minus 65, 4 over 42. That will be giving me 2 over 21. That is my y. Then I'll be getting my z. I'll be getting my z by saying z is equals to, I'll clean what I did for the one of y so that I will not make mistake. So for z, we will say this will go to this will go to this, and this will go to this. This times is minus 28 over 42 plus this times is, that is minus 35 over 42. This times is plus 49 over 42. So that will be giving us, this will be giving us 63 minus 63 plus this, minus 63 plus 49. That will be giving me minus 21. Wow. So I'll be getting minus 21 over 42. That will be giving me 3 here, and 21 here, 21 here. That is 3 here. Is it 21? Let's check it. 63 and 49. 14. Right? Oh, thanks for not making mistake. Minus 14. Minus 14 over 42. Okay. This here 1, this here 3. So minus 1 over 3. So that is how to solve this using matrix method. That is, get your determinant of the matrix. First of all, package this to be a matrix form such that it starts with x, y, z equals to inverse of the matrix times the constant. Get the determinant of the matrix. Get the adjoint of the matrix. Then transpose your cofactors to finally get your adjoint. So get the determinant, get the adjoint, multiply inverse of the determinant by the adjoint. After multiplying it, the answer you get, use it to multiply the constant. Whatever it gives you, while following this pattern, using this arrow, is your answer. So that is how to solve it. Let's note that this is over 21. Thanks for watching the video.